Welcome to the Deepak Saini Show.
He said he gon' huff and puff and blow my mind up. You meet the island girl, she might dirty wind up.
Welcome to the Deepak Saini Show. I'd like to thank J23 for the intro music. You can find a link to her music in the show description. My guest today is Dr. Paniz Jasbi. He's the co-founder and chief science officer of Theriome. Theriome? I know I was going to get that one. Inc., specializing in the integration of AI with systems biology data to advance personalized healthcare. His research focuses on mass spectrometry-based metabolics. Dr. Jasbi's work, notable for its emphasis on innovative diagnostics and precision medicine. He's dedicated to leveraging systems biology and advancing bioanalytics to develop transformative health solutions, emphasizing a data-driven approach to health optimization and disease prevention. Paniz, welcome to the Deepak Saini Show.
Thank you so much for having me, Deepak. Excited to go through
Yes, I'm so excited to have you. We had a conversation before. I had the opportunity to visit your lab with one of your senior members there. And just heads up, everyone, there's going to be some supplemental footage at the end of the podcast here today. And I totally butchered the name of the company, so my apologies. Can you please pronounce it properly for me?
It's Theriome. So the theory of omics sciences, like
Theriome. Okay, perfect.
Theriome.
Perfect.
Yeah.
Theriome. Awesome.
Yeah.
And yeah, we're going to talk about that a little bit more as we go on. But I always like to start my interviews. How did you get into this line of work, and what even got you to doing what you're doing?
Yeah. The path to any research position is usually this very non-linear cursory trajectory. And that's the case for so many people that I've talked to, for me, it really started with an interest in neuroscience. I don't do any neuroscience anymore. It started with this idea that, okay, well, how does the brain dictate perception and behavior and cognition and all the things that we think of as psychology? How is that rooted in biology? And so I started to have a deep interest in neuroscience and genetics. I started working in a neuroscience lab, looking at the effects of a certain receptor. Looking at the effects of CD36 characterization of differentiation 36, which is a medium and long chain fatty acid transporter. It's expressed everywhere in the muscle, the cardiac tissue, as well as our taste buds. And so it is in the papillae of the mouth, and it is responsible for fat taste. And so I started to perform these experiments using mouse and rat models with and without CD36 knockout to test their perception of fat using a conditioned food aversion learning paradigm. Over some time, I started to realize that, well, the mice and the rats that were capable of tasting fat consumed more fat preferentially, and that had an effect on lipid metabolism. So I started to get really interested in lipid metabolism. And when we started to test for these lipids, we kind of had to do that sort of, one by one, or fractionation with high performance liquid chromatography, which is a very slow sort of tedious endeavor. My mentor at the time, who I was working with, suggested that I work with another professor who was new to the college, Dr. Highway Gu. And I was exposed at first to metabolomics because he had the ability to look at all these lipids in these animal models, their tissue and their plasma, et cetera, using high throughput mass spectrometry based metabolomics and lipidomic techniques. So I was able to look at not just one metabolite or one lipid, but hundreds of metabolites and hundreds of lipids at once. And I sort of became fascinated with the analytical chemistry that underlies metabolomics and the science and statistics behind diagnostic work, which was almost what I was doing in the neuroscience field. My neuroscience mentor actually ended up passing away in my transition between my master's and my doctoral program. No. Yeah, she had glioblastoma, and so she passed away, and she was an excellent mentor. And it was recommended that I go into metabolomics, and it seemed like a great fit. I already had this sort of budding interest in the field, and I was naturally good with it. I had a proclivity toward analytical chemistry and statistics, two fields which I had studied a lot during my undergrad. So I had some familiarity with the field already. And so under the direction of, Dr. Highway Gu, I began developing both mass spectrometry methods for the enhanced identification and quantification of metabolites with GCMS, LCMS, as well as applying those methods for the detection of biomarkers for the creation of either in vitro diagnostics, of point of care diagnostics. My work is mainly designed to help identify diseases at an earlier stage using, more cost-effective, less time-consuming, less invasive methods that can catch disease, usually at an earlier stage where prognosis and treatment options are greatly improved. So that is the story. And again, like most scientists, I took a very cursory route to what I ultimately decided to
So
specialize.
I love what you just said there, because for the layperson who's watching this, they'll be like, cheaper, faster.
That's it.
If I have
Cheaper,
stuff,
faster, less invasive.
less invasive. That's what people care about. So I would love if you could just really briefly talk about what metabolics is for the lay person. Not everyone's going to have our level of knowledge. So
Sure. So metabolomics is the study of metabolites and their dynamic interactions within systems. Now, that system can be a cell, it can be a human, it can be an animal, it can be wastewater, it can be plant matter. Those are all systems, biological or otherwise. And just like genomics is the study of the genes and their interactions, the entire set of genes, metabolomics is the study of those metabolites. So in the hierarchy of systems biology, if we're following the central dogma of biological expression, we start with nuclear DNA. We then go from nuclear DNA to RNA, the transcriptome, right? From the genome to the transcriptome. That is then translated to proteins, or the proteome, the complete set of proteins and their interactions. Most people are familiar with the microbiome, of course, all the bugs and archaea, fungi, viruses, parasites that live on us and in us. And then the metabolites. And these are the very sensitive and specific indicators and the final level of expression. Metabolomics sits at that intersection between the gene and the environment. Metabolomics is the most important layer to probe if we're talking about, explaining variance in nature-nurture interactions, right? It's that nexus point of where it's immediately downstream of the genome and immediately upstream of the environment. So it's this layer that's incredibly informative and contains lots of rich biological data, especially when we talk about, monitoring those diseases and pathogenesis that are most contributing to human morbidity and mortality, like cancers, Alzheimer's disease, heart disease, other neurodegenerative disorders. They're not completely environmental. They're not completely genetic. They are a mixture of both. And so metabolomics gives us a very attractive layer to probe.
So let me ask this question that I know people listening, the audience is asking, like, okay, maybe I have my genome test done and I have a propensity, or I have one of the markers that makes me slightly more susceptible to XYZ disease, whatever. Where does metabolics fit in that as far as prevention, as an example?
Sure. So let's say you are positive for the ApoE44 allele, which would, I wouldn't say predispose you, but I mean, it would mean that you have a propensity for early onset Alzheimer's. And we usually see this genetic variation in individuals with a familial history of Alzheimer's. In such a case, you have, anywhere from, let's say, like a 20 to 80% chance of developing early onset Alzheimer's. But we don't know. We don't know how that gene is being expressed, how it's interacting with other genes and proteins and RNA and how those lipoproteins are then interacting with gut bacteria, et cetera. We don't know. We know that there's the blueprint there, right? You have a sort of blueprint for this. It doesn't mean it's going to be built that way, right? If you've ever baked a cake, let's go away from blueprints and architectural design. If you ever baked a cake,
like my cakes don't turn out exactly like
if you follow the recipe, right? Like it should, but you can follow the recipe and think you're following the recipe pretty closely, but the end product is really the complex product of all of the dynamic steps that happen upstream, right? From, what the ingredients say, what ingredients were available at the store for purchase, how much money you had to purchase the best ingredients, what are the, kitchen equipment that you're using, are they high quality? Did anything fall out of your grocery bag on the way home? Did you lose anything? That is all very much analogous to systems biology expression, very parallel to systems biology expression. And so the cake is the metabolome, the final finished product, which is, again, the complex product of all the dynamic processes that happen upstream. So if you want to know, what probably went wrong with the cake, you don't look at the instructions, because there's a lot of what ifs, right? If a chef wants to know what went wrong with the recipe, they'll taste the food, they'll taste the cake, they'll taste the end product, and a clever chef can tell you exactly what you did wrong. Did you not reduce as much? Did you leave it in too long? Did you not add the vanilla extract? Whatever the case may be, a clever chef would to see what's wrong with a cake or what's right with a cake. They wouldn't look at the recipe, which is what the genome is. So there's a lot of ambiguities, right? When we look at, like I said, that Alzheimer's gene, it can assert like a 20 to 80% predictability. That's a huge difference,
That's
right?
a huge
20%,
variance. Yeah.
right? Do I have a huge rate? Do I have a 20% chance of early onset Alzheimer's, or is it more like 80? Because those are totally different scenarios. With the metabolism, we are not looking at what could be. We are looking at what is. What are you right now? And unlike the genome, the metabolism is dynamic and reactive and reflective of changes you may make. So I may look at your ApoE4 allele and come up with some sort of wildly varying prognosis or risks percentage for you. But if I look at your metabolism, I am looking at where you're at currently, not what you could be given the blueprint, the recipe. And then I can also give you, treatments and recommendations. We do that at Theriome with our digital twinning platform. I can give you these very personalized recommendations on what to do to address your current metabolic aberrations with relation to Alzheimer's or any other sort of disease, and then retest you. And because the metabolism changes, the genome does not change. The genome is a very static, or there's no change in longitudinal expression. Epigenetics do change, but your base pairs do not. So we can change, we can analyze this through time and use the metabolism as a very dynamic and objective barometer of treatment efficacy, whereas the genome cannot be used for therapeutic monitoring subsequent to treatments.
Absolutely. I love it the way, especially that last sentence there, cannot be used for monitoring, whereas metabolics can. Which brings the question people are going to be asking, and maybe this is a good point. So full disclosure, I didn't get a chance to do my test yet. I have it here. I'll be sending it in. I'll be doing follow-up posts on my what I learned from it, as I love to share with my audience what I'm doing. But I think the audience is going to be asking, okay, I do one, I get my data. You guys give some recommendations. How frequently should I be retesting? I think that's the number one question people are going to be asking themselves right off the bat.
Sure. Well, good news is we tell you. We take your metabolomic data, which is a collection of 126 aqueous metabolites indicative of 80 different human pathways. It is 3 times more ampliative. We collect 3 times more data with this one test than you would get with the CMP, BMP, liver function test, thyroid function test, OAT test combined. 3 times more than these 5 tests combined. And we're looking at 80 different pathways. We're able to look at 72 different organs, tissues, and subcellular localizations, such as liver, cardiovascular, mitochondrial health, et cetera. We're able to look at 480 different disease states and their test for statistically significant enrichments in those states. We're also able to look at 4,598 different SNPs and see if you have significant enrichment for those single nucleotide polymorphisms. And we also look at 62 different environmental and drug toxicity exposures. So it's a very comprehensive test. And then we take all that data, 126 metabolites, and we deconstruct you to a digital twin. We mathematically abstract a metabolic replica of you with your data. And then on that replica, we will go ahead and simulate various interventions that we have mined from the scientific literature. So we have taken studies that have, let's say, looked at niacin supplementation. And we have looked at studies that have used the mononucleotide version of niacin, maybe niacinamide ribonucleoside, NAD+, oral liposomal NAD+, various versions of that. And then we will simulate each of these versions 1,000 times. at different dosages, different times of day. We will simulate them with and without meals. We do that for every single one of the 1,300 interventions we have banked. So your digital twin undergoes 130,000 simulations in order to produce a very personalized protocol that addresses the most ubiquitous metabolic aberrations identified in your metabolomic profile. So that would be, yeah, go ahead.
Sorry, I don't mean to interrupt. I think this is a question that not only I'm having, I'm sure other people as well. Is like,
Sure.
so obviously we're getting recommendations, but there's some people, not everyone, but there's some people, like myself, be one of them, and a lot of people I hang out with are like, are doing interventions without maybe having the full data. Like sounds good, or someone else is doing this, or the literature says this, or in a mouse model, and they're doing stuff. Does the report or the end result not only give recommendations, but also like, you should not be doing this. You should definitely not be doing. Okay, perfect.
Yes. So
who knows? I could be doing biohacking stuff that I should not be doing.
Should not be doing. Yeah. So when we simulate those 1,300 interventions on your metabolomic profile, we then view your metabolism's response, right, to these diet, lifestyle, environmental changes, exercise routines we're recommending, intermittent fasting, specific HIIT training protocols with very specific durations of on, off, retest, recover, recycle periods. And then we're observing your digital twin's reaction to these. And we start to then rank order them from most effective to least effective. And invariably, there will be a subset of those 1,300 interventions that are predicted to be detrimental. Or you may be taking, for instance, very high doses of ubiquinol, but we're not seeing a concomitant improvement in your mitochondrial health. So we may alter the dosage, or we may ask you to switch the form of that or remove it entirely from your protocol. Oftentimes, we see individuals who come in, like for instance, they're taking T3 synthetic hormone. They're also taking a very high dose of magnesium at the same time as that T3 synthetic hormone, unbeknownst to the physician that prescribed the synthetic hormone.
Right.
So the magnesium is actually competing for absorption. And they come to us and they say, oh, it feels like my medication's not working. Because again, unbeknownst to the physician, they're taking this magnesium that they thought would be great, that the literature said would be great, that they heard some sort of health influencer on Instagram say would be great.
That's a good one.
But it's contraindicated.
I didn't recognize that contrainterdiction between those two. So yeah.
So we have that into our AI that is baked in, so to speak, that it can identify contraindications or any sort of misalignments between medications, lifestyles, supplements, dietary preferences. A lot of people come and they're carnivore diet for 6 years, and they're metabolically completely aberrant, and we're saying, well, hey, that's great for an acute phase for your metabolism, but you also need to introduce some whole grains, some berries, maybe a turmeric supplement, et cetera. And so we again, it's all mined from the literature. And so the retest timeline, going back to your original question, is also based on the literature. In the case of, let's say, liposomal glutathione, we have randomized control trials, we have case cohort trials, we have observational trials that have done usually some sort of baseline and retest assessment. And that time, right, that is the length of time that they've retested to observe the effects in the metabolism. In science, we use a statistic known as power. A power equals to 1 minus beta. Beta is our chance of type 2 error, or our chance that we'll miss an effect that's actually there. So we always want to make sure our power is 80%, that we have at least an 80% chance of catching an effect if it's being chronically expressed. So we always look at these studies and we see, was it 4 weeks? Was it 8 weeks? Was it 18 months? How long did the study take to get an 80% of power? And if they didn't achieve 80% power, we extrapolate a little bit longer to the time point where we feel like they would have achieved 80% power, and that becomes the recommendation. So let's say you were recommending liposomal glutathione. It's based on 5 studies. Those 5 studies had an average follow-up time of 10 weeks. They had 100% power. So we say, okay, we only need 8 weeks, right? Because 8 weeks would give us 80% power. So retest in 8 weeks. And it's also contingent on the individual's metabolic profile and their scores across the 12 key health domains that we monitor. Individuals with really sort of diminished profiles with low scores and high aberration, they might be recommended to retest, in 8 weeks. Individuals who are very healthful and in fact optimize across these 12 domains, they may be recommended a longer retesting timeline, such as 18 months. But usually it's a mixture of how their baseline scores and how either poor or optimized their metabolism is, and again the interventions that are coming from the scientific literature and how long they waited to achieve power. And it's a mixture of these two, but usually retesting timelines for our customers are suggested anywhere from 3 months to 1 year.
Okay. If I could just in a nutshell for people, sicker you are, once you start an intervention, you should test more frequently. The more optimal you are, you can tweak things and probably don't need to test quite as frequently.
Exactly. You've got it, Deepak.
Yeah. So, Paniz, you mentioned, digital twins twice, you mentioned AI, and I think, that's a big topic in all industries, AI, of course. I'd love to hear, how you guys are seeing, AI driving, the future of, preventive medicine and healthcare, I guess.
Right. So yeah, AI is really transforming metabolomics and personalized health assessments. And there are so many implications to AI-driven diagnostics, and the science of healthcare delivery. So as I mentioned, there are significant implications for preventive medicine. And so just to give you an overview, really the main thing that I see right now is that AI can handle really, large data sets generated by metabolomic studies, things that the human brain absolutely cannot compute, things that traditional frequentist statistics, even things such as brute force combinatorics and approaches that are very sort of let's look at everything all at once. They cannot do the pattern identification and correlations that are incredibly difficult, if not impossible, for humans to detect. And these machine learning algorithms are constantly improving, and they can be trained to recognize biomarkers and metabolic signatures associated with specific health conditions, again, enabling more accurate but more rapid disease diagnosis. And then also what we do with our predictive modeling is mostly risk assessment. So we can predict the individual's risk of developing certain diseases based on their metabolic profile, allowing for potentially early interventions. And with our digital twinning, we analyze that metabolomic data, and our AI can help design these personalized treatment plans that are really tailored to that individual's unique biochemical makeup. And so when we start to really look at this integration with genomics and other omics, we start looking at integrative multi-omics. AI is going to be the main driver of that when we pair this with genomics, proteomics, and other layers of omics to get a very comprehensive and deep metabolic profile, or a deep molecular fingerprint on this individual. And these multi-omics approaches will inevitably be the future of medicine. They will greatly enhance our understanding of disease mechanisms, as well as, on the other hand, the development of these very targeted therapies. And then in the world that's kind of outside of Theriome, where we currently don't have integration, but we're working toward it, are wearable devices. So these AI-powered wearable devices, I saw this like Samsung Ring that is so much more computationally advanced than like the Aura rings that are very popular currently.
Oh, really? I have to look into that. Okay.
Yeah. So these are, very, AI-powered wearable devices, and they can, in some cases, monitor metabolic markers, not metabolites, but metabolic markers like heart rate and blood oxygenation, et cetera. And they provide real-time continuous feedback that, a lot of people have mentioned does inform their health choices. So they make their treatment plans and their lifestyle recommendations based on that. So when we talk about preventive medicine, though, healthcare delivery, again, we are looking at shifting from a reactive paradigm to a proactive paradigm. And AI is the tool for that, where these AI-driven diagnostics and molecular tests like Theriome's Aristotle test, we can identify disease at an earlier stage before symptoms appear, and then allow for really timely intervention that prevents this progression. And, ultimately, this is going to have very widespread societal effects where we reduce healthcare costs because, of course, early detection and prevention reduce the need, statistically speaking, for more expensive treatments and hospitalizations, overall reducing the cost and healthcare burden on the nation. And again, personalized medicine, we look at all of these 80 metabolic pathways that we can detect with the Aristotle test, and we're targeting substrates, dietary changes, exercise routines that are going to largely ameliorate this person's aberrations as detected across the entire biochemical circuitry of an individual. And patients are very engaged with this because this is a form of engineering now, whereby we're not just predicting, but with our recommendations, we are helping this patient cooperatively engineer their health trajectory for a more healthful future. So, I mean, as far
Love
as
it. Yeah.
efficiency and accuracy, we have very high diagnostic accuracy. We have very high operational efficiency as well. Even at Theriome, I mean, we have convolutional neural networks that perform statistics. We have a large language model that generates protocols. And if you go to our website, we have a Theriome bot that will chat with you on anything from your health conditions and
I'll have to
disorders.
test that one out myself.
Yeah.
Hey,
And
before we go too further, I want to just circle back to a couple things before. So two things. One, I love how you said like your fingerprint, right? Because I've been saying this for a while, and it's a message I'm trying to get more. Your individual health is as unique to you as your fingerprint, and listening to the mass, recommendations or some of these heck, even myths we've had in our health society for decades, it's not going to serve you to where most people I think want to go. So I just want to point that out. I love that you said that. Number two, I'm going to kind of make up something here, but I think people generally get the idea. So you talk about risk and risk prediction. So again, this is not a commentary on anything I'm about to say. I'm just using this as an example. So for example, someone was like doing carnivore for 6 years, like you said. You're gonna the test can show, hey, if you continue on this path of not having these other type of nutrients in your diet, your risk of XYZ is increased by 2 times, 3 times, whatever. Is that the kind of level we're from a risk prediction point of view type of thing that
we can calculate that? It's not something we report. We do, however, report, hey, if you do these recommendations, this is where you'll be in 3 months, 6 months, a year. We do report that. We can calculate, obviously, the inverse, where we say, if you continue on this health trajectory, this is where you're going to be in 6 months, 3 months. We don't report that in the report. That is information that our customers may get in their precision consultation. So when you get your report, Deepak, you'll meet with one of the MDs or PhDs on our team, and you will always meet with somebody who is either highly experienced in the practice of precision medicine or a PhD that is a scientist in molecular biology. And that is the level of knowledge that we feel is necessary to answer questions and guide you in your report. Now, the report is very easy to read. One of the main bottlenecks of metabolomics and systems biology testing has always been, how do you communicate this wealth of data to the layperson, and without it being overwhelming, with it being digestible and cogent. And so one of the things that we report is, hey, this is where you'll be in 6 months if you do these recommendations we've given you, which is where we predict you'll be. And as you retest, your digital twin becomes more accurate, because now we start to be able to calculate a delta or a difference between how we predict you will react based upon people like you in the scientific literature and how you specifically reacted.
Right. And then the overall data with more data points and more clients becomes better as well.
Exactly. Yes. So it becomes better. We don't lose the forest for the trees, right? We can see the forest and we can zoom in on, the veins of a single leaf on a tree, which is you. And that is the beauty of data aggregation and AI, is that these models are constantly improving on a weekly basis at Theriome. And so we have this ability to absolutely tell an individual, this is where you're going to be. And here are the few factors, these nexus points in your health trajectories across these 12 scores that are really determining your outcomes, whether that's lipid peroxidation, NF-kappa beta signaling, maybe AMPK activation. We see in a metabolic profile that there's 3 or 4 bottlenecks that are really what is driving high scores or low scores, right? And we want to ameliorate those as best as we can, either sustaining them or fixing them and improving them so that the scores go up. These scores are not, aging as a concept, which is one of the things that we measure with our tests. We have 12 domains. One of them is aging. Aging is based on a bunch of things, right? If you improve cardiovascular health, if you improve liver health and mitochondrial health, aging scores usually go up because they're usually contingent on the same pathways. Aging is a construct, not an organ.
Right.
Not a right. And then same thing goes with, environmental toxicity. If we clear up environmental toxicity and we help individuals identify heavy metal burden and bind them, chelate them, excrete them, sweat them out, whatever the case may be, exercise, sauna. And we usually see concomitant improvements in liver scores because the liver now has less burden. And we also see improvements in mitochondrial scores because one of the first things that environmental toxins do across the 63 classes of environmental toxins we monitor is impact mitochondrial efficiency. So these are all linked. Usually there are 3 or 4 underlying factors that, if addressed, will really sort of raise all the ships in the harbor, so to speak.
Yeah, I just want to mention one thing. I know you're for some people are maybe not as familiar. Don't get all. I haven't done my test yet, as I mentioned. Going to do it soon, but I've seen the sample report. Very easy to read, as Paniz said. So don't get all caught up in like the scientific lingo or whatever. It's a very easy report to read for the layperson listen there. And I'm very excited, and obviously that's why I wanted to have you on. Very excited about what you guys are doing. I'm so glad we got connected a number of months ago. You guys are still a relatively new company. What are some of the challenges that as a newer company in this very exciting and growing space that you've guys have come up against, and I'd love also to hear how you've overcome them thus far.
Yeah, so some of the challenges were at first, our challenge was really how do we communicate metabolomics? So the first version of this test was really just, here are your levels of your metabolites. Here are the, reference averages for low and high levels from the scientific literature in human blood. And here is a general description of the metabolite. Here's implications of low values and high values. So it was a report that was, 126 metabolites, your levels, the range levels, and then a paragraph on what is this metabolite. Something like shikimic acid was discovered by a Japanese scientist in the 40s, looking at mushrooms, and then implications of low values. What are the health associations of being low, and what are the health associations of being high? And that was kind of the first pass of this test, and people were just going through it one by one, and this didn't address one of the shortcomings of metabolomics, is that it's highly sensitive, but each metabolite by itself has very low sensitivity or specificity. So what do I mean by that? It's sensitive, so we can detect metabolites at very low concentrations. I mean, most metabolites are being expressed at the micromolar concentration. We can detect that even lower, 2 orders of magnitude lower. So at the picomolar level, or sometimes even at the femtomolar level. Very trace amounts of ibuprofen in the blood that come from pollutants that people aren't aware of. And so it's sensitive because of the mass spec platform is run on, but it's not specific, meaning that one metabolite, if it's high or low, could be related to heart disease, Alzheimer's, and gout. And it's like, okay, which one, right? What's important is that we build models for Alzheimer's and gout that are contingent on a few metabolites, whereby we say this magnitude of this metabolite plus this magnitude of this metabolite plus this magnitude of this metabolite plus an error score. This model is specific to Alzheimer's or is specific to gout or heart disease, whatever it is, right? But each metabolite on its own, high or low, usually points to either no conditions that we know of or a few conditions, and they're all kind of relatively disparate. So how do we reconcile this? Is we build models. That is the science of metabolomics and diagnostic medicine, is we build these bioinformatic models that speak specifically to this, that if you have these ranges of these 3 metabolites, chances are that it's more likely than not this thing, right? Rather than the other thing. And so we started to build these health domains. Now that became the next part of the report, was what are the domains that we can mine and validate. And there's tons of steps, and I won't bore you with it for the sake of time. There's tons of steps in statistical validation to make sure that this model, when it's trained on the training data from the literature, can then be extrapolated to test data, which is our customers every week, every day, right? We have these test data that are being given scores based on the training data. So we got to make sure that these two match up and they're validated and not overfit, a bunch of other considerations. So we built scores across these 12 health domains from the scientific literature, looking at specific sets of metabolites that are very sensitive and specific, and therefore highly accurate when we start to look at cardiovascular health, mitochondrial health, aging, liver, mutational load. And they can speak to things like, what kind of environmental toxicity do you have? What is the issue with your mitochondrial health? Is it the TCA cycle? Is it oxidative phosphorylation? Is it substrate utilization? Is it beta oxidation of fatty acids? How's your electron transport chain functioning? Do you have good throughput of adenosine for generation of ATP? When we look at cardiovascular health, we're looking at things like arterial stiffness. We're looking at things like, ejection fraction. We're looking at things such as, calcium and neurotransmitter innervation of the cardiac muscle. But there's like 8 aspects of cardiovascular health that we're able to tell in that domain. So we started to now build these models. When we look at neurocognitive health, is it stress that's reducing your GABA levels? Is it screen time that's reducing your serotonin levels? Is it some sort of trauma or fatigue that is being caused? What is the cause of this? We have models for this. Even things like I mentioned, screen time. There is a biochemical signature in the metabolism and the microbiome, and we can look at that signature and roughly gauge how much screen time do you have a day and what effect is that having on your body based upon previous studies. Some of them are ours.
So I can just interject for 1 second. So this is what I'm hearing. Correct me if I'm wrong. Version 1, here's all your scores in a reference range. Great knowledge, maybe not so useful to implement. Now the use of the models and everything you've been saying, pick an area of concern. Here's the 5 metabolics that we've found and the literature says affect this one thing, and now you have 4 of the 5 or high or low, whatever the case may be. It's like now we actually have an action step for
we didn't have an action step. We have a directional. Now we know what's going on. So first the report was just, here's your data individually on a univariate level. Here's what these metabolites mean. Version 2 was when we combine them in multivariate models. Now we can look at constructs and domains like health metrics and aging and et cetera. Nutritional index, right? Integumentary, inflammatory, all these things. Now we can speak to constructs and processes when we combine these in discrete sets from the larger set of 126 in the panel. Then the third step became the digital twinning. And this was something that we, as a group of scientists at Theriome, especially in our sort of skunkworks division, we call it Systems Precision Engineering and Advanced Research, SPEAR. The SPEAR division of Theriome, we had started to develop digital twinning models. Now that's the directional step. So now we know we know what's there, we know what it means. What do we do about it now? That became the digital twinning step, whereby we said, okay, we have this individual, Deepak's metabolic profile, and we see aberrations in TCA cycle substrate utilization. We see aberrations in cytochrome pathways of the liver for detoxification. We see aberrations in lipid peroxidation. Let's go through all the interventions that we have, simulate the effects, the directions of change, the magnitudes of change, clinical significances, beta coefficients, whatever we can, and let us simulate these effects each 1,000 times with slightly different changes in dosages, time of day, everything. And then let's view the response from Deepak's profile. And we will recommend to him what was predicted in silico to be the most effective.
Right.
This is a tool that now allows us to test on the silico version of Deepak what we can't really feasibly do for the in vivo version of Deepak. We can't
take too many variables. It would take
1,000 times. You're gonna die. Your lifespan will naturally run out before you go through all of these. So in a matter of about 16 minutes, and it's a very computational and cumbersome process, but we are able to produce this very cogent and personalized protocol that adequately addresses all of the most ubiquitous aberrations.
And that's why I'm so excited about it. That's why I'm so excited about what you guys are doing. As we do, last couple of questions as we slowly wrap up here, but what are you most excited about when it comes to development of new technologies in the health field? Maybe it's stuff you guys are doing or other stuff that you're seeing in the industry. What's got you the most excited about technology in healthcare?
Oh man. Okay, this is really gonna be like the best part of this interview. So obviously what we're doing really right now, when we talk about these exciting developments and what's coming, not just in the industry, but what we are developing here at Theriome, is really interesting. I would say, first of all, we are publishing research on a monthly, if not quarterly basis related to artificial intelligence and machine learning, new predictive analytics, personalized treatment plans, diagnostic imaging. We have some things going on in with regard to where we're applying some algorithms to diagnostic imaging and seeing how much more accurate they are than human interpretation. So that's the research arm. That's what we're doing. With regard to telemedicine and remote monitoring, as I mentioned, with every single test that individuals get, they will consult with not just some ambiguous healthcare provider, but an MD or PhD that is either in precision medicine or a molecular biologist from the comfort of their own homes. So this is really one way that the model of medicine is shifting, which is improving access to care and reducing the burden on physical healthcare facilities. In the future, probably within the next year, we will launch integration with wearable devices. So we're going to continuously monitor vital signs through these wearable devices, and we're going to allow for real-time data collection. And this is going to really merge very well with the metabolite data that we're getting off these dry blood spots and the gut bacteria data that we're going to start getting off of our soon-to-launch gut microbiome test for identifying these health issues and chronic disease management. And then one thing that we're also kind of interested in, we do research in, we're not obviously going to offer this in humans anytime soon, but Theriome does do research in CRISPR and other gene editing tools to look at treating or even curing genetic disorders by precisely modifying DNA. And then, of course, pharmacogenomics is a big part of what we do, where we do perform pharmacodynamic and kinetic experiments on your metabolite profile to see, hey, are you supposed to get this spermidine through diet, or are you supposed to get it through a supplement? What's better for you, or is there no difference? Because if you have a suspected genetic mutation upstream that is impacting the activity of an enzyme that is required to take the supplemental version of spermidine and render it in a bioavailable form for absorption, and you cannot do that, you can't perform that reaction to render bioavailable spermidine, we're going to probably ask you to get it from wheat germ and soy products. So the pharmacogenomics is very interesting. We're also launching a blockchain. So our goal is to have blockchain technology, which we know is going to ensure very secure and transparent sharing. And it allows actually for just to have decentralized patient health records, but also allows still for this very trustless, incredibly secure public ledger of data without necessarily throttling data sharing, which is the backbone of scientific enterprise.
Right.
We want to have a marketplace where individuals and research institutions and organizations and hospitals can come to us and say, we want data on postmenopausal Hispanic women, and we can give them a list of anonymous EIDs that contain that are for those individuals, and they will approach those individuals on our network and generate a smart contract and say, we are so-and-so, and we want this part of your data for this amount of time for this stated research purpose. And if the patient consents to allowing their data to be shared, the patient will actually receive the lion's share of profits for giving their data away. Some profit has to go to Theriome for maintaining the network,
Sure.
And collecting the data, but it is not completely out of the question that when a person tests with us and stores their data on our blockchain, and if they regularly consent to data transmission and where they're receiving funds for it, that the cost of the testing over X amount of time may pay for itself. And this completely upsets insurance models, and it completely upsets.
Good. They need to be
absolutely they do,
upset.
and it completely undermines the FDA, which really holds the keys, right, to the kingdom as to whether your test is insurance reimbursable. Is it approved for X, Y, and Z? And it really just kind of throws the current model, which is garbage in my opinion, right into where it belongs in the waste bin. And then we also have some idea. We do some research again on this for looking at 3D printing. Like I have done some personal research into, and it's not published yet, but 3D printing of a cell mesh for a synthetic pancreas, which could be used to implant as a graftable, non-rejectable biomedical device for individuals with type 1 diabetes, for instance. We can also 3D print very customized supplements for individuals, whereby if we're recommending a stack of supplements across 12 pills currently, and we don't sell any supplements, like when we give you recommendations, we're not selling you a diet plan, we're not selling you a health coaching exercise routine, we're not selling you supplements. We are a data collection and analysis company. That is what we're here for. So you do not have to worry that there's a conflict of interest between what we're recommending.
And just for everyone, that's why I love you guys too. That's another thing that was a big draw for me. Yeah.
Yeah, it's what everyone loves because there's no conflict of interest. We're not selling you a test with our left hand and a supposed solution with our right hand. And then also we're doing some research with some scientists here at ASU looking at nanotech and medicine with using these nanotech particles, these nanoparticles for very targeted drug delivery to disease cells, which, as we've shown in our publications, really minimize side effects and improve treatment efficacy. So these tiny nanobots can be designed to even perform precise diagnostic and therapeutic tasks. So that's what I'm most interested in when it comes.
Yeah, I love this. We share that. One question that came to mind as you were talking there. So how do I describe this? Okay, so we'll use me as an example, right? So we're going to build my digital twin right over time with all the comparables and everything like that. If some new drug comes to market, for example, and of course, that's assuming you have all the research and all the everything. Can we now take the theory, or maybe it's not the right word, the model of this new pharmaceutical against my digital twin, and it's like, oh, you know what? This is not going to work for you, Deepak. It'll work for 80% of the people, but for you, it won't work.
Absolutely. And I would say even Deepak, theory is the correct word. That's why we call ourselves Theriome, because it is a constantly evolving landscape. And as new studies come out and as we integrate these studies, either by using very selective AI crawling mechanisms or manual curation, we read a study in our team. It's a very good study from a very good group in a high impact journal, very well reviewed. We might integrate, and the methods are sound, the conclusions are valid. We may integrate that into our database, and we use AIs to do that, and we do that manually too. So as the landscape changes, so do the theories. And so that is something that we constantly do. As new stuff comes out, it's integrated, and we are able to quickly and dynamically assess whether that's a good fit for you. And right now, of course, we get a lot of people who come to us and say, "What about GLP-1 agonists? And what about semaglutide? And what do I do?" And we have a wealth of data banked on that and can give them very precise and
very cool. That's I think that's the most exciting thing. As we wrap up here, again, this is not a health podcast. Obviously, we're talking about health. This is not a health podcast per se. But I do like to always ask my guests, what does your morning routine, or what does your health regime look like?
Oh gosh. Oh my gosh. Okay. This is so embarrassing. All right. So I'm a pretty early riser, and I don't sleep much. Just how I've always been. And so I usually get up. I will usually start the day with if I do exercise, I'll probably get on the Peloton and bust out a quick hit regimen. I don't have too much time. 20, 30 minutes is all I'll probably do. And then I don't eat breakfast. I go straight for the espresso. Usually do 3 or 4 espressos. And then usually I'll start doing some trades. You know, I manage my own portfolio of stocks, and so I'll usually spend about an hour doing that. And then it's off to work. I'm at work, you know, so 5 waking up, at work by 7:30 to 2. I'm usually doing like the very big tasks of the day, research and development, operations, whatever is going on at Theriome in our laboratory here. You can see behind us. And that's the bulk of my day. And then at 2 p.m., I don't eat lunch. I do a form of intermittent fasting called OMAD, 1 meal a day. And we have tons of our own data and publications on intermittent fasting. We actually recently published our latest intermittent fasting protocol in Nature Communication. So a very high impact journal, very good research there. And we show different effects of intermittent fasting protocols. So I don't exercise as much as I do. I would say that I'm actually very healthy, both in terms of conventional diagnostics as well as our own molecular testing, and looking at my whole genome before, and looking at proteomics and some of the tools that we have in our lab that we haven't really deployed to the customer and the end user yet. So we have a bunch of things we can do on ourselves that we can't really offer yet.
Sure.
And looking at all these layers, I'm doing exceptionally well, thankfully. I really should probably exercise more. You know, I got to be honest, every once in a while I'll have a cigarette. I'm not too health conscious. The thing I would attribute most of my health to is, number one, the 1 meal a day. The body is not meant to have 3 metabolism challenges a day. That is not how we evolved. I'm a staunch supporter of intermittent fasting. I'm also a staunch supporter of a balanced omnivorous diet. Vegan diets are incredibly detrimental to one's health, as are carnivore diets. The answer is something in the middle. Hydration is key. I usually am consuming anywhere from 3 to 4 liters of water a day. Now, of course, we live in the heat in the desert of Phoenix, Arizona, but making sure that you have the water. I mean, H2O is a cofactor for so many metabolic products. You actually create some water too in your metabolic processes. It's called metabolic water that's made endogenously through metabolism. Right. But you need lots of water. People are chronically dehydrated. Chronically. I mean, that's one thing we see in so many individuals. And then the most important thing, aside from the one meal a day, is that I absolutely consume no processed foods. Nothing. Everything I eat. I mean, I drink water, first of all, out of these glass Mountain Valley spring. My wife and I spend almost $200 a week on just water, but it's worth it. It is really worth it. Drinking tap water, I mean, filtration processes are good. They're a little bit difficult to keep up on. I don't have the time. The glass water can just be delivered to your door. It's in these glass bottles. It's very clean spring water, so it's electrolytically balanced. The foods I eat are always, fresh vegetables, fruits, whole cuts of, primal cuts of beef. I eat a lot of beef, lamb, chicken. So that is, turkey for tryptophan and things like that. I eat very whole foods. I don't have anything that's cured, processed. I do eat some, fermented or pickled foods, of course, for gut health. Lots of cheese, lots of aged cheese for spermidine and all the rejuvenating compounds contained therein. Honey for gut health. Diet diversity and moderation is probably what I would attribute really to my own health. And of course, again, a philosophy that is really embedded in Theriome and everyone in this company is that we eat very whole foods. And if you take a look around you, even the foods you think are healthful are in many ways processed. So just making sure that you're getting a raw ingredient, it's so empowering when you realize that I'm totally agnostic of metabolic scores. Just this improved sense of well-being that's almost immediate when one adopts a non-processed, completely whole food diet. It's amazing.
I love that. I just want to add one more thing is like whole foods that are also still right for you, because there's a lot of perfectly healthy foods that might not be right for you, and certainly you can trial and error those for yourself. And
those are great terms and conditions. Yeah,
for myself as well. Paniz, I want to thank you again for being on the Deepak Saini show. I really appreciate this conversation. We could riff on get all geeky and sciencey for another 3 hours, but I do know you have to go. I really appreciate your time. Any last, I know we got a couple of minutes here, any very briefly last words of wisdom or anything you want to leave the audience with?
Yeah, we're no longer in a world where you only get a very sort of narrow view of your health. It's akin to, you're in a locked door, there's a room behind that locked door, and you're looking through the lock or the peephole to see what's in that room. We now have the tools, and we've had them for some time actually, but we now have entities like Theriome that are operationalizing these research tools that are only in research laboratories like the ones behind me, and not in your hospital systems, not in your clinics, to allow you to open that door and look through the door. You don't have to look through the peephole. And
kick
you don't
the door down.
Kick the door down. Yeah, kick it down. I like that. And you don't have to try every little thing, different ways to figure out what's right for you and listen to whatever health influencer is currently in vogue and whatever health trend is currently in vogue. You can look at the entire system, and you can use very highly advanced computational techniques like digital twinning, among others, to personalize and identify what is best predicted to be most efficacious for you through time, and really reduce the time and cost of experimenting on yourself, because that's what I think most people are doing, and that's not the paradigm we have to live in anymore.
I love it. I just want to say to the audience, don't forget to check today's sponsor out. Also, remember, we're going to have supplemental video at the end, but I went to their labs and did a tour, and we're going to have a little bit of that there. I'm going to throw it back to J23, who's going to guide us out with some music. Dr. Jasbi, thank you again for joining us. And everyone, thanks again for listening to the Deepak Saini Show. Remember, exceptional results for the exceptional you. Till next time. This episode is brought to you by Bioptimizers. I love their product, Gluten Guardian. Now, I'm not celiac, but I am sensitive to gluten, and sometimes you just can't avoid it. You're out. Sometimes you just want to celebrate that, birthday cake that your kids made, what have you. So I'll pop a couple of these pills just to help mitigate the inflammation and help break down the gluten that I may ingest sometimes. So Gluten Guardian also works with dairy as well. I take these occasionally, and click the link and you can save 10% off at least, if not more. Cheers.
Podcast produced by the Minted Green Company.
Comes in, we actually bring it right over here to the minus 80 until we process it. That way we just make sure that it's stable. Obviously, it's gone through the mail system. It's not a big issue. We just want to make sure that there's not going to be any issue and it has good integrity. So yeah, all our samples are stored here as we go through processing. We also keep any backups that would be required if we have to redo the process. And that's oftentimes based on the user not properly putting their blood sample on the spot. So that's why we do have people take 2 blood spots. So when you actually are processing this sample, we'll go through a number of steps where we're basically, breaking down the paper that it's basically a blood card, right? So we have to break that down and separate it out from the whole blood. So we'll do that here through a number of processes using different reagents. We'll actually come over here and use the centrifuge to then pull that all down so we can get the supernatant, which is the sample that we actually need to work with in terms of capturing the metabolites that we want to annotate. Yeah, so we'll actually put each individual sample in a bead tube, where you can see these little beads in here. We'll actually pulverize the sample, and it's actually quite violent. This is an example. So we'll do this for 20 minutes, really breaking down the sample, making sure that we lyse all the red blood cells to release the metabolites that we actually want to capture.
All right, so this is the dryer.
This is the dryer, nothing really fancy. We just have to dry the sample. Because we are using gas chromatography, we need to make sure that there's basically no liquid, because we're actually looking at the volatile compounds that are going to pass through the helium stream when we go into the GCMS. So, yep, nothing fancy, just drying the samples here. For gas chromatography, when we're looking at metabolomics, vital to the analysis, to the whole process really, is the helium. So it's coming down this copper wire, it's going in, it's providing a stream where when we heat up the sample, these are all samples that we're running right now, it's actually going to travel on that stream, go through a coil, and in that way we can get the retention time, we can actually calculate the mass and get the annotations here where we can actually see what they are and what they correspond to in terms of peaks in our metabolite library. So we're looking at, for our particular testing, Aristotle 126 targeted metabolites.
Okay, so you said, Alex, you said 126 different metabolites. How does that compare to your competitors?
So for metabolomic analysis, I don't believe there's anyone out in the commercial realm right now that is offering a test like with GC or LCMS. So none really. However, you can go through a lab or a university system. They're not going to provide you the type of report that we have, and it's going to be very, very expensive and a long-term amount of time. And actually, I don't even know how you would go about doing that. So I guess my answer is none.
So basically, only through some sort of study or something, it's something to get this outside of your guys' lab.
Right.
Awesome.